Hi, this is part 2 of lesson 13.3, where we are going to be talking about radians and degrees and how they relate and how to convert between the two of them. So first of all, a radian is the angle made by taking the radius and wrapping it along the edge of a circle. So if we take the radius, that length, and if we wrap it around the circle, it would go this far. So the number of the angle then that would be formed going from here to here, this angle is called a radian. Now, if you think about the formula, circumference is 2 pi r. All the way around a circle is a circumference. Well, we're going to talk about how many degrees around the circle. So we're going to put 360 degrees equals 2 pi times the radius. So 360 degrees would mean that you take the radius and wrap it around 2 pi times. So when you get, this is 0 degrees or 0 radians, and when we go all the way around, it is equal to 360 degrees, which is the same as 2 pi radians. If I divide by 2, we have pi times the radius, and that equals 180 degrees. So if you take that radius, pi times, which is about 3.14 times, you have 180 degrees. And that would be pi radii, the radius wrapped around pi times. So that is equal to pi radians. So that's what we need to understand, that 180 degrees equals pi radians. And that is going to be our conversion factor between the two. So if you look at a unit circle then, this is 0 radians, 0 degrees is 0. Pi radians would be 180 degrees right here. And then all of these other important measurements that we use a lot are just fractions of pi. So let me kind of go to a blank screen here. And let's talk about how we can label the quadrants here. So this would be 0 degrees or 0 radians. This is pi radians, which is 180 degrees. So this would be 1 pi. So 90 degrees would be 1/2 of pi. So it's pi over 2. Or I'm just going to write 1/2. It kind of is helpful to kind of think of the fractions. So this is 1/2. This would be 2/2, which makes 1. This would be 3/2 pi. So, and then this would be another half, which is 4/2, which is the same as 2 pi. So 360 degrees is 2 pi. So now we often use 45, 45, 90. So if we take, all right, this is 180 or 1 pi right here. If we break this into 4 parts, so if we break 90 into half, that'd be like a 45 of 45. Break this into half, so we have 45, 45, 45, 45. That would give us 180. And so this is, we broke it into 4 parts here. So 4 parts. So this would be 1/4 of pi. So this is 1/4 of pi. This would be 2/4, which is the same as 1/2. This would be 3/4 of pi. This is 4/4, which is the same as 1 pi. So we're going to break these up too. So then this is another 1/4 right here. So this would be 5/4 of pi. This would be 6/4, which is the same as 3/2. This would be 7/4 of pi. And this one would be 8/4, which is 2 pi. Then we'll do one more here. Some other typical angles we use would be 30 degree angles, 60 degree angles. So we're going to take 1 pi, which is 180 degrees, and divide it into groups of 30 degree angles. So that would be 6 of them. So we're going to take 1 pi and divide this into 6 equal parts. So this is about 30 degrees. This is about 60. And then you have 90, 120, 150, and 180. That would be 210, 240, 270, plus 30 degrees is 300, 330, and then 360. So taking 1 pi, then dividing it into 6 equal parts here. So this would be 1/6 the pi. So pi over 6, so that's 1/6 pi. This would be 2/6 the pi, which is 1/3 pi. This would be 3/6 up here, which is 1/2 pi. This would be 4/6 pi, which would be 2/3 pi. And this would be 5/6. I can't reduce that, I'll write it right there. This would be 6/6. This would be 7/6 pi. This would be 8/6, which can be reduced to 4/3 pi. This one is 9/6, which is the same as 3/2. Then we have 10/6, which is 5/3 pi. And then we have 11/6 pi. And lastly, you have 12/6 pi, which is 2 pi. So the best way to do this is just to practice on blank paper, doing these a few times till you get good at it. Okay, now we're going to talk about converting between radians and degrees and back and forth. But first we're going to review dimensional analysis. So with dimensional analysis, when you want to convert 10 centimeters to inches, you use unit multipliers. So between an inch and a centimeter, you have 1 inch equals 2.54 centimeters. You can either multiply by 1 inch over 2.54 centimeters or by 2.54 centimeters over 1 inch, because these two values are equal, these are equal. So it's the same as multiplying by 1, so it doesn't change your value of 10 centimeters. So 10 centimeters. And when we want to convert to inches, what you want to do is choose the unit multiplier that has the centimeters in the denominator so that it cancels. So you write 2.54 centimeters, so that the centimeters cancel, I should say, 1 inch in the numerator. Now, centimeters cancel, so what we have is 10 times 1 inches in the numerator divided by 2.54. And then the last step then would be to simplify. So you could just divide 10 by 2.54. Let me grab a calculator here. And you get approximately 3.9 inches. Let's say that you wanted to convert, in the next example, 6 miles to feet. So you write 6 miles over 1, and then you're going to multiply by the unit multiplier. Now, 1 mile is 5,280 feet. So you're either going to multiply by 1 mile over 5,280 feet or 5,280 feet divided by 1 mile. We want the mile to cancel, so we're going to write the miles in the denominator, the feet in the numerator. So 1 mile is 5,280 feet. The miles will cancel, so then we have 6 times 5,280, which is my calculator's not working right here. 31,680 feet. There we go. All right, now let's go back to radians and degrees. So the relationship again between radians and degrees is that pi radians equals 180 degrees, and 180 degrees equals pi radians. So when we want to convert 125 degrees to radians, we'll start out by writing 125 degrees. We want to end up with radians, so what we have to do is choose the one that has the degrees in the denominator. So pi radians over 180 degrees. So now the degrees cancel here, basically. So what we have is 125 pi over 180 radians. Now, we always want to reduce our fractions. And if you recall, when we were working on putting these on a quadrant, we used fractional amounts of pi. So we want to keep this as a fraction. So we'll reduce. You can either use your fraction key on your calculator, type in 125, ABC 180, and your calculator will reduce it. Or you can say, what is the common factor? Well, 125 is divisible by 5 25 times. So divide out of 5, you get 25. 180 is divisible by 5 36 times. So that is equivalent to 25 over 36, 25 pi over 36. So 25/36 of pi radians. Okay, so that is your answer. Next, we have negative pi over 12 radians. And we want to convert to degrees. So what you're going to do is you're going to choose a unit multiplier that has the radians in the denominator. And with degrees, we want to just get a decimal answer. So the radian units cancel, the pi's cancel. So we have negative 180 over 12. And you can divide that out. And you get 15, a negative 15 degrees. All right, here's another one. Convert to degrees. So this is radians. So 5 pi over 4 radians, and we're going to convert to degrees. So we want to put the radians in the denominator, degrees in the numerator, so 180 over pi. So the radians will cancel, the pi's will cancel. So what we have is 5 times 180 degrees divided by 4. So 5 times 180 divided by 4 is 225 degrees. And one more, this time we are converting degrees to radians. We write negative 50 degrees, and we want the degrees to go in the denominator so that the degrees will cancel, and then we would have pi radians in the numerator. And remember, when we have radians, we want to have a fraction. We don't want to have a decimal. So if you type in 50 ABC 180, the calculator will reduce it for you. So it's negative 5/18 pi. If you don't have a calculator, if you have 50 over 180, the zeros cancel, so that's 5 over 18. So you can also do it that way. All right, and then you have a worksheet to work on. It looks like this. I'm getting to it here. So number 1 says find the measure of each angle in radians. So if you have 30 degrees, you write 30 degrees over 1, and then you're going to multiply by pi radians over 180. So what we end up with is 30 over 180 pi. And then we just reduce our fraction, so that would be pi over 6 radians. Let's do another one here. Let's say we have 270 degrees, so we multiply by pi over 180. Now, if you use your fraction key, you get 1.5, and I want you to keep it in fraction form, so then if you hit second degree, the ABC button, and enter, it will turn it to 3/2. So you have 3/2 pi radians. In the next part, you have radians, and we want you to convert it to degrees. The radian goes in the denominator, and 180 goes in the numerator. Here your pi's will cancel, so you end up with, this is radians here also. So the radians cancel, you end up with 2 times 180, which is 360 degrees. In the next one, you have 2 pi over 3 radians. We want to convert to degrees, so we're going to put 180 degrees over pi radians. So then the pi's will cancel also, so you have 2 times 180, and then divided by 3, And your answer is 120 degrees. On the back side, it says the measure theta of an angle in standard position is given. Find the exact values of cosine and sine for each angle measure. Well, pi over 6, if you were going to graph it, and you could graph it as pi over 6, or if that's a little bit confusing, just convert it to degrees. So to convert to degrees, you would multiply by 180 over pi. And so the pi's cancel, and then you have 180 over 6, which is 30 degrees. And then if you'll recall from lesson 13.2, you graph a 30-degree angle. And then we make a right triangle, so come back to the closest x-axis, and then label according to, this would be 90, this would be 60, so the extended ratio of all 30, 60, 90 triangles is across from the 30 is 1, hypotenuse is 2, and this is root 3. From there, you can say the sine of 30 is opposite over hypotenuse, so 1/2. Cosine of 30 is the adjacent over the hypotenuse, so square root of 3 over 2. So those are some examples for you. So go ahead and finish up this worksheet. Let me know if you have questions. Thanks for watching.